All right.
Fine.
Welcome everybody. This is our second virtual Kubernetes Atlanta meetup. Thanks for joining us. Still working out some of the kinks with it, but think we've got it down pretty good. Joined today again with fellow co-host Alex Barnes here. We got a great lineup of speakers, all from our local Kubernetes community here in Atlanta, which is awesome. And then based on some previous feedback and past meetups, we have kind of diversified our subject matter a little bit to cover both intro, intermediate, and advanced level topics and everything. So please give us some feedback after this. Let us know what you think on that. I want to thank SalesLoft for sponsoring our virtual location today. They've graciously provided us with a Zoom webinar again. And a super big thank you to our speakers that we have this evening as well. Always love it when we get to feature our own community members here. So again, if anybody is interested down the road in speaking, please reach out. Doesn't have to be anything super in depth. We can help and work with you to help structure a topic or anything like that. Before we get into this month in Kubernetes, I want to ask all folks that are hiring or folks that are looking for positions, please post in the webinar chat. Make sure you include your name, your business, what positions you're hiring for, or looking for, and some form of contact information to you. And then after this month in Kubernetes session, I'll kind of read through those on the call so we have them recorded. That being said, I'll hand over to you, Alex, to tell us about what happened in Kubernetes over the last month.
Great. Let me get this sharing. Give me just a moment, folks. All right. Everybody seeing HackMD here? All right, so this is our HackMD. This is available either on HackMD or on the GitHub repo for posterity if you ever want to look at any of this stuff. As Joe mentioned, we do the call for who's hiring. That'll get filled in here and be available, listed local positions and things like that. Any details we get sent will be here to check out and see if you're interested in any of those roles. So moving on to the news. In the last month, we've had some kind of interesting things develop. Istio 1.6 was released. Some interesting develops there are they're doing canary deployments now for the actual control plane objects. Networking components are sensitive. It's nice to be able to get a little bit more stability and guarantees in your deployment process for those sensitive components. This is something I thought was really interesting reading through the release notes, is that they've specifically called out a lot of improvements around bridging non-Kubernetes environments into the Istio mesh. They specifically call out virtual machines, so kind of coming up to parity with the more kind of like NSX networking environment where you can bridge multiple environments together rather than being only cloud native or now bringing in the legacy environments as well. This I thought was super well timed. So Azure AKS has added an optional paid SLA option. This obviously being a direct response to GKE adding a mandatory fee for the control plane in order to add an SLA. There was kind of a big community uproar saying, this really changed a lot of people's pricing models and a lot of the sales guarantees that had been made to them. And people felt that while it makes sense to be able to have an SLA guarantee around that control plane, that should have been optional. Microsoft probably very cleverly swooped in and did exactly that, gave the people what they wanted. It's pretty reasonably priced. I won't dig into it too far, but I thought that was a pretty clever way of handling that situation and a great way to kind of get some marketing against Google there. This not a massive thing, but something I thought was really interesting is AWS CloudWatch has added the ability to scrape Prometheus endpoints and natively support Prometheus metrics. So now you can run the CloudWatch client inside your clusters and actually scrape Prometheus endpoints. So, kind of Prometheus becoming not just the standard monitoring tool, but the actual format itself becoming kind of a standard way of consuming metrics, similar to what we saw around Docker's image format becoming a standard image format rather than just Docker itself becoming a standard. I thought this was a really cool development, really great way to kind of dip your toe into consuming Prometheus metrics without having to do the setup yourself and see if it works for your organization. A lot of information here available on the blog post, which again is linked to from HackMD. Harbor has released 2.0. That's a really quick turnaround. I don't know if, how many of you remember Harbor 1.0 being announced, but it's not been that long. That is a VMware project, I think, coming out of their branch in China. Originally, this was supposed to be a more enterprise-friendly Docker registry with a lot of great scanning features, high availability, distributed abilities. And with 2.0, they're pivoting towards being, you can think of it almost as going towards like a cloud native artifactory is what they're really targeting. They've added the ability to push things like Helm charts up, open policy, agent policies. I actually don't know if policies is the right word for OPA artifacts, but I'm guessing. And I think there are plans to add more. So it still supports images and things like that, but they're really driving towards being your one-stop shop to store all of your artifacts, which is super interesting. Artifactory, super awesome project, but really cool to see an open source alternative emerging there out of Harbor. Helm graduated CNCF, so now I fully graduated CNCF project. This happened not long after our last meetup. I thought that was super cool, great thing to call out. This one is a bit of local news. So T-Mobile has joined CNCF as a gold member. Now, usually these kind of business changes aren't things we would announce at the meetup, but the reason I wanted to call this one out is because my esteemed co-host Joe Searcy actually had a big hand in motivating T-Mobile to become involved, not just with the CNCF, but with open source itself. He got there and has told me multiple times it wasn't a culture that was super big on open source yet, and he's done a lot of work to help them mature that, and they're all in on it. They're not just talking about it, they're doing it and they're investing in it. And this is, I don't know how many of you are familiar with the kind of the tiers, but gold, that's a big investment. That's a significant contribution to the community. So I wanted to call this out to show just how one member of our own local community just kind of doing the work and being an advocate can really make a big difference. Super cool thing. So congrats to T-Mobile there. Kubernetes is updating to using Klog version 2. This is more of a dev consideration because this is going to be a significant change to how logs are consumed out of Kubernetes. If you are using Klog v1, I think this is as of 119. Is that correct, Joe? It's going to switch to v2. So if you're doing a lot of structured log consumption or using Klog v1 in any of your tooling, you need to be sure to be ready for that upgrade at 1.19. Oh, this is another big one. So kubelet no longer registering these tags on the API servers. So beta, Kubernetes IO, OS, and /arch. It's no longer going to be registered. That was deprecated as of 1.14, but if you're anything like me, you see deprecations and always think, I'll get to that later, and it becomes a bug in your backlog infinitely. These will stop appearing as of 1.19, so check your tooling. If you're doing tooling around consuming tags and things like that, around your API servers, make sure you're not expecting these to be here, or make sure you're not using those to identify API servers. And then 1.19 beta 0 is published. I think we're going into feature freeze. Is that right, Joe? Yeah, so feature freeze is out there. So now we're in the phase where things that have been accepted, have been announced, are being matured, being written, being PR'd in. So 1.19 is underway after that initial delay we saw, where the release crew was trying to take some stress off of people and take, give people more time to do this release, to take stress off people during the shelter-in-place orders. One small thing I want to share as well that's not listed here is we have actually gone back and uploaded all of our previous meetups to YouTube. So any meetup that you're interested in watching again or seeing the details of, they should be up on our K8s ATL YouTube channel now. So we've got a good bit of content up there. This meetup will end up there as well. So go check it out. We've got a lot of great content from the community up there. And that's it for the news.
Cool. Thanks for that, Alex. A lot of stuff going on, a lot of cool, interesting stuff, a lot of stuff to keep an eye out for. So now I just want to kind of read out, we had 2 postings in the chat around hiring. One is from Tim Dorr with Spaceship. They're looking for systems programmers that work heavily in Kubernetes and Go. have contact info there that we'll have posted out on the HackMD and on our Meetups README on GitHub. And then also our good buddy Lawrence from Real Theory, hiring open roles in front end, back end, .NET Core, or Go, machine learning. These are a little bit different. These are not full-time roles. These are part-time roles, about 5 hours per week only. Work anytime, so very flexible. Real Theory is a local startup here in Atlanta, so we'll have that information captured, and if that stuff seems interesting to you, feel free to get that info from the README and reach out to those folks as appropriate. So that concludes our normal startup for the meetup here. So are we going to Shahar first, or? Okay, all right, cool. So yeah, again, we have 3 great speakers this evening, all from our local community. We love to see that stuff. And kicking things off to start with here is our good buddy Shahar Levy, works for VMware, and will be talking to us about Kubernetes ingress controllers. So take it away, Shahar.
Hey all, let's see. Cool. So you know, a lot of the talks that we give are really advanced. You'll see later. Two of them are. Today I'm going to talk about something that's a lot more accessible and sort of fundamental to Kubernetes, and it's ingress controllers and how you get traffic through your cluster. So before I talk about ingress controllers, let me bring up something a little bit simpler. There's another way to get traffic into your clusters, and that's just to expose them through services. So as you know, pods have ephemeral IP addresses. Services sort of allow for a way to have a pointer to pods, right? And so you can use either a node port, which isn't load balanced. It's just a node with an IP to expose your services. You can also use a load balancer, which can get expensive. You can use a service of type load balancer, and then for each service that you'd like to expose, each microservice that you'd like to expose externally, you're going to end up provisioning like a cloud load balancer, and that cost can really add up. One of the things that we mentioned at the beginning of this meetup is the cost for the SLA for like Kubernetes master servers. And a lot of the costs that that you end up paying for Kubernetes is still not the cost of the master server, but all of the compute and the network and all the cloud resources that you end up consuming. So it matters there. Also, services aren't like the most flexible and powerful for just routing rules, where you can do that with ingress. So what is an ingress? An ingress is usually the single entry point for your cluster. You can just think about it as a reverse proxy like HA proxy or like Nginx. Unlike a lot of the other Kubernetes resources, so when I make a pod, right, like I give it like an image to pull from a repository or a registry, and it's just going to create that pod for me. Same thing with a lot of the other Kubernetes primitives. Ingresses aren't quite like that. You can make an ingress spec, but it won't really mean anything until you install an ingress controller. And so you have a couple of different options for the ingress controllers that you want to use. Nginx has a very popular one. You can use Traffic. I'm from VMware, so today we're going to demo our open source ingress controller, which is Contour. So you do have to install it before you sort of get started with that. And so here on the right-hand side, I have an example of an Nginx ingress configuration. And so again, I want to call out, like, this is for the ingress spec, but it's not for the ingress controller, which has different considerations. When you install it, you might install it with the default configurations, which would include like the appropriate rules for it to watch all of your resources so that they can route to them and see if they're healthy and things like that. So on the right, things things that you can include in your ingress spec are the default backends. If none of your routing rules match, you'll be able to like route to maybe a 404 page. You can have like different rules for your routing. Usually you would want like a path-based rule. So you have an endpoint slash service or service A, endpoint slash service B. And you would set that up in this way. How do we go back? Sorry. Now, one of the things that's sort of a weakness in the ingress space right now is a lot of the things that you tend to want to do with ingresses end up presenting themselves as annotations. So here you can see, I don't know if you can see my mouse, but you can see there's only one annotation here, and it's for a rewrite on the path. So in this ingress example, there's a couple of defined paths, foo and bar, right? And so I would go to this endpoint, foo.bar.com/foo/bar, and the service that it ends up reaching doesn't actually know about that /foo or /bar. It just knows that it's where it's at. So I actually want to remove that. Like that's an example of something I might use an annotation for. There tends to be a lot of them, and a lot of the logic in these ingress controllers ends up presenting itself as really bulky annotations. So before I get to the demo, let me just say, ingress controllers or the ingress object is currently a beta object, and so there is work to make it a V1 object and take a lot of those things out of the annotations and put them, bring them to a home in the proper spec, right? And so I have a link here about just talks about it coming out of Google, where they talk about introducing like a gateway object that's like the load balancer that sits outside, and then different types of routes, and then putting in each of these routes all the configurations that a service team might want to provision for themselves. And so the demo that I'm going to be talking about today is going to be Contour, which is an open source custom resource ingress controller. It is an attempt at doing just that, at taking a lot of the annotations and putting them in a home in the spec. It also has some interesting things like DNS delegation. So today, if you have a bunch of teams and you have this Kubernetes across your entire org, and say that you give each team a namespace, which is like a really common model at a bunch of companies, they can ask for the same piece of DNS, right? And when they try to provision to carve off the same DNS space, that behavior is undefined. So you get conflicts that are not fun. So one of the things that this project does is it additionally allows you to delegate the DNS from a root ingress to a vertex ingress below, and you're not going to be able to have that conflict. But anyway, so getting into it. So I have here a terminal, and I think that this is pretty big, but if someone can't see, then let me know. And I'm going to run this locally. So I'm going to pray to the demo gods here. The only thing that I have here is a kind cluster, just a local Kubernetes cluster. And so if I say kubectl get pods, nothing's on here. Kubectl get namespaces, haven't touched it, made it an hour ago. So the first thing that I'm going to have to do is I'm going to actually have to install this ingress controller. So let's do that. So I'm just going to install and embarrass myself because my path is wrong. Okay, so as you can see, there's a lot of things that are sort of deployed in this ingress controller. We made a namespace for it. We made service accounts for it and role bindings for like RBAC, defining the rules that it's going to be able to do. This is the very basic like install for this object that watches your services and watches your pods and checks that things are healthy, and has like a like a panic threshold for whenever enough of these health checks fail. So this is just a proper, you can think of it as a reverse proxy, but it needs permissions, and this is deployed in like a Kubernetes way, right? Additionally, the one that I'm deploying, Contour, is using Envoy as its routing backend. So it's, you don't have to know too much about it, but you can pass configuration into Contour as this like Contour object, and it'll go apply it to this Envoy backend. If you know about that, then Contour is like the XDS server, and Envoy is the client. So if I want to start routing things, and I want to demo routing things, I actually need the things to route to. So I'm just going to apply just a couple of apps. So here you can see I make a new namespace, and I deploy 3 apps. I deploy a root app, a secure app, and a secure app default. So you'll see what those do in just a sec. They'll just echo back the request that I sent to them. And now I'd like to make a the actual like spec for this ingress, like and give it some rules. So let me take this out here. Cool. So this is a pretty simple spec for this ingress. It's a custom resource. It's an HTTP proxy because that's what it's doing. It's proxying my HTTP requests. I have like a fully qualified domain name that just says that this is the root ingress controller here, and the ones that this isn't a mandatory field. The ones that I can delegate to would not have a fully qualified domain name. And then I have just 2 services. So we deployed 2, but I'm just going to look at, or we deployed 3, but we'll just look at 2 right now. We have a root app and a secure app. And one thing that you might notice is the secure app is going to have the prefix that we've carved out for it, /secure. So if we go to local project contour.io/secure, we'll hit the secure app. There's nothing secure about it other than I routed to it on that path. I'm hosting it on this path. So let's just deploy this just to see that. So it created this HTTP proxy. And if I go open up Firefox, and now I have a lot of things on my screen. I feel kind of bad about this, it's messy. And I go to local.projectcontour.io, and I zoom in because I'm sure that you can't see that. You can see, so I went to not the secure app, not this image that was hosted on that secure endpoint, but just projectcontour.io. And this is the default app. So I'm routing to it that correctly. It's got the root namespace. So if I go anywhere, I'm just entering a bunch of gobbledygook in my URL, and it'll still route there because this is taking the root path. Alternatively, if I go to the secure path, I'm now on the secure site. So it just switched to say secure. And so I'd like to show just one more thing. This is path-based routing. I'd also like to show some header-based routing. You can route in some really flexible ways. So this is one really common use case. So I'd like to I'm going to update our ingress controller manifest. And now I'm going to use that 3rd service. So here we use just the root and the secure service. And so now we're going to introduce the secure default and the secure app. So we're only going to allow people to reach the secure app if they're on Chrome. So the way that we're going to do that is that we're going to have a condition here. And so notice one of the things that I mentioned about the ingress space is that a lot of the times this is going to be in the annotation. Like this entire sort of condition is like text in an annotation. So here it has a really proper, like it sort of makes sense that in this route, I route for it based off of this condition. And the condition is that my user agent in the header contains the word Chrome. I can also have like an exact match. I can also say it doesn't contain something. very similarly in this spec. So I'm going to apply this and wherever my terminal is. So we're going to apply this. Oh, copied a bit too much. Cool, and so we've just updated our ingress or controller spec. And now we have 3 endpoints that we can hit. So here I am on Firefox, if you're not recognizing it. And if I try to go to the secure site, I'm just going to go to the default secure site because I'm not on Chrome, right? And you can see if I open up Chrome and I try to go to that same site, to that secure site, this time I'm going to be able to reach the secure site just because it reads from my header and it routes based off of what I had in my header. And you can actually see that this is an echo server. So it's really just echoing back that request and saying whether I'm hitting the default or the secure app. So in this header here, I'm using Firefox. Here I'm using Chrome, and I'm routing based off of that header. So this is a really common thing that you would do using an ingress. I know that usually we have a more advanced topic than this, but I wanted to have something that was a bit more fundamental, and I invited a bunch of people that are new to Kubernetes. So hopefully someone got something out of this. So that's it for me. That's all I really had to say. Does anyone have any questions?
So people can't, feel free to throw your questions in chat. I'll give you a minute to put them in there.
Yeah, and so this is, it's really easy to get started with this. You can do through this like canary deployment by giving something like this here in the, on the route, you can give it like a weight. And you can give it, like 80% of my traffic goes here. So very similarly, you can do a canary deployment in that way. This is all about like getting traffic into your cluster. Really, as you mature your cluster, one of the things that you'll find is the community has been rotating around. Oh, hey, yeah. So Lawrence actually asked, is there a canary deployment example? So I don't have one here. Like I don't have a. I won't try. I won't tempt the demo gods. But like, yeah. So if I hosted these all on the same endpoint, so say I actually have, this secure app default and the secure app here, and I'm just going to prefix secure. I can actually have also a weight here, and I can give it, like a weight, so like 50 and 50. And so it would be, like 50-50. And so the weights are arbitrary. It'll just add them up and divide by the total amount. Will this work? Am I tempting them? It says, why did it say unchanged? I'm editing. I won't tempt the demo gods here, but yeah, that's just how you would do it. I don't know the configuration or where this goes off the top. Cool. So is there anyone else in chat?
Yeah, we have a couple others. So Anil asked, can you repeat how using ingresses saves cost against using load balancers?
Yeah, totally. So every time, say that I have like 10 services in my cluster, all the 10 microservices, and they need to be like accessible from the outside. And I set them all up using a service of type load balancer. Each of those services, the way that they actually get provisioned is the cloud provider that you're using is going to take the liberty to set up a cloud load balancer. And each of those cloud load balancers, like literally the cloud costs for that compute is expensive. And it adds up a lot quicker rather than if you just have an ingress, you have one load balancer for your ingress, and you might have all these services that aren't exposed externally. So your cloud provider does not set up all of these load balancers, these cloud load balancers. And so you just end up paying less on that compute cost. because less of them are provisioned. Does that make sense? I hope that makes sense. If it doesn't, then cool. And it looks like John asks, does it support custom ports other than 80 and 443? Absolutely. So your app, whatever port it exposes, you would want to, or I should say your container, whatever port your container exposes, you can just put it here, whatever port that is. There's no preference here. You can make it any port. You have your app, which might be like a server that listens on a port. You containerize that. Then you can sort of watch the Docker container can watch that port and listen on a different port or the same port. And then similarly, each of these can listen on the same port, a different port. It's very flexible. It doesn't. Does this support gRPC? So the way that this like custom ingress controller is set up is it talks to Envoy with the gRPC, the routing backend over gRPC, and then each of the applications, yeah, I guess so. I don't see a reason why you wouldn't be able to go over HTTP and make like a gRPC connection. Yeah. Yeah, so definitely. Cool. So I think that's about it. Yeah. So all of this stuff is really just about enabling traffic. But one of the things that's, as I was saying, is becoming a lot more mature and is getting a lot more traction in our ecosystem is about securing your cluster, getting. How about UDP? I've been told that actually, yes, but there's no documentation. So I don't know, good luck. Exercise to the reader. Yeah, so we've been like securing our clusters, and as we've been maturing, one of the really great practices that we've been coming up with and that people have been implementing is pod security policies. So it is my pleasure to announce or to introduce Jason Price, with a much more advanced topic and much more interesting than mine. So are you ready? We're kicking off.
Okay. Moshe, can you share your screen? All the demo luck went to you and none of it went to me. So not only can I not share my screen right now, I can't see what other people are sharing. So this is going to be a bit of a fun exercise. So this talk is about pod security policies and how to sleep better at night while annoying your security team. So slide 2 is disclaimers are everywhere. So slide 3, I do work for Square, but I do not speak for Square in any way, shape, fashion, or form. So this is just me talking about something that I found useful. Slide 4 talks about how there's a blog post accompanying all of this stuff. And if you want to read, to get actual copies of the source code, I strongly encourage you to go look at this blog post because it has all of the source code in question in a little bit easier to copy paste format than, well, presentations or a keynote or anything else. Anyway, on to the meat of this talk. Slide 5. So Kubernetes is incredible. Slide 6 shows us that it's powerful. Slide 7 shows that it's flexible. But with all of that power, that was slide 8. Slide 9 is a picture of Syndrome because, well, these movies are awesome. Slide 10. Kubernetes is a big old hairy beast with a very complicated relationship with security because there's a lot of dials and knobs that you can turn, and many of them in their default positions are more open and forgiving than they should be if you are doing anything interesting or have a higher security bar than Twitter for pets or what have you. Slide 11 talks about how I tend to break down Kubernetes attack vectors into 2 major fronts. First one of them is if you don't secure the Kubernetes API, you get what's coming to you, and all sorts of bad things happen. And the other vector of attack is attackers would attack the workload, break the container isolation, and then attack the Kubernetes API or the workers or whatever. This is a pretty significant oversimplification. Slide 12 talks about how Microsoft released an attack matrix for Kubernetes, which was a very, very good read if you are at all interested in how to run secure workloads in Kubernetes. It has 31 different things that it goes over, and there's a link here that I won't read, but if you just Google search for Microsoft Kubernetes attack matrix, you'll find it really, really quickly. Slide 13 gives us a very scary picture of Pennywise, but slide 14 is, fortunately, pod security policies help you deal with 9 out of those 31 vectors and largely helps you with one of my half pains. So what is a pod security policy? That would be slide 15. They allow you to have really, really fine-grained access to what things can execute and how they execute against the Linux kernel, how they syscall restrictions, what privileges you are allowed, whether you're allowed to have host ports, whether you do host paths, different kernel capabilities, what UIDs you're allowed to run as, and a bunch of other very useful things. So what does one look like? Slide 16, please. This is from the official Kubernetes documentation. It just simply blocks privileged pods and allows everything else to run as whatever you want to do. This is good as far as it goes and is a very useful documentation exercise. But unfortunately, slide 17, if you just install this, you've probably broke everything. Either that's your expectations of things being secure or your workloads itself, because some things do require to be privileged. Slide 18 talks about, look, this talk is not about how to enable the PSP admission controller. It's not about where to slot it into the admission controller ordering. I'm completely ignoring that huge pain point, and I refer you to the official docs on how to set this up from whether your provider or from the Kubernetes official documentation. I am more interested in this talk is about how to run a real example of Kubernetes pod security policies at scale with exceptions, which the documentation doesn't talk about at all. All right, slide, what is that? 19 is, we're going to start talking about what a real pod security policy talks about or looks like. So the next 3 slides are going to be a bit of an eye chart, and I apologize. And again, please look at the blog post rather than actually trying to copy any of this information down. Slide 20, please. All right, now we get a mile of mice type. But the first things you'll see is there's a couple of annotations that have a nice description. There's a couple of secure computing set comp things that allow you to set runtime default, which are ways of isolating which syscalls the given process is allowed to do. Then we have some very useful comments, which for when we get to exception management, we'll show you the syntax of how to actually allow a capability for, say, Envoy or Istio, or how to allow a host mount path. But these 3 slides enumerate every single control that pod security policies allow in their exact in their most lockdown configuration. So we see things like FS group is allowed to have UID of 1 or higher. Host IPC is false, host network is false, et cetera, et cetera. The second slide of this trio of slide 21 covers required capabilities drops. This shows that, hey, the sysadmin capability is dropped, the chroot capability is dropped, netbind service is dropped, et cetera, et cetera. This is every single capability in the Linux kernel. And the third slide of this trio, slide 22, limits every single UID to be greater than 1 or greater, which removes all root UIDs, GIDs, supplemental GIDs, et cetera. And the final control here is which volume types are allowed to be mounted by the by the various pods. So in my case, this is config map, downward API, empty dir, projected, and secret. I am explicitly disallowing host path and persistent volume claims at this level because I'm running in Amazon and persistent volume claims are a bit challenging. Anyway, slide 23 shows a little bit of relief now that we're finally done with this eye chart. But wait, you just made a pod security policy that's not associated with anything or anyone. So we need two more things. Slide 25 covers the cluster role that you need to use to make this PSP available. And the interesting piece here is that it has the verb use, which is the only use case of use in the Kubernetes API that I'm aware of. And it specifies which policy and the verb of use. Slide 26 talks about the cluster role binding for this. And note that both of these things have a naming convention associated with them so that we can find them. In my case, they start with PSP and then a usable name. And in this case, the subject of this cluster role binding is all system authenticated users. All right, we just went through a mile of mice type, but yay, slide 27 shows that everything is now running restricted. This is awesome. Slide 28 covers some of the challenges that you run into immediately if you were to implement what I just typed. Slide 29 says, yeah, we're going to need some exceptions. We're going to work through an example of how to build exemptions for FluentD. We're going to working through all of the stuff like kube proxy, core DNS, everything else in kube system. Unfortunately, that's going to be on you because there's many variety of different clusters out there and different ways of doing business, and they're all going to be subtly different in what they require. But kube proxy is probably going to need to run as privileged so that it can actually modify the IP tables rules. All right, slide 30 shows the first part of our exceptions list for FluentD. And so this is a pod security policy named after the namespace and then the service account. And in this case, FluentD needs to be running as privileged mode with a root user ID and a root GID so that it can read the root owned and root only visible logs that are on some Linux systems. And the volumes, this one needs to have a host path included so that FluentD can actually mount these volumes. Slide 31 talks about how the FS group, the run as group, run as user are all allowed to use UID of 0. And slide 32 builds the custom cluster role so that for this particular PSP. And finally, slide 33 talks about the custom role binding or role binding. Whether you use a role binding or a cluster role binding is very much an implementation detail. There are pros and cons to both approaches. So, but both of them are more than effective to get what you need done. All right, slide 34. So yeah, that's a lot, but with this system, you have a lot of advantages. The first advantage is you can very clearly find every single exception by just running a diff between your restricted policy and whatever other policies that have existed out there. And if you followed the examples that I was going with, every single one of those exceptions had the big word exception and a comment by it and why it was needed. By following this pattern, when your auditors come calling, they will be go away happy and leave you alone more or less because you have all of these things documented right next to the code. So, but I kind of buried the lead here because I haven't talked about how we're going to annoy the your security practitioners. So what's going to annoy them is A, you're running a much more secure environment, and B, all of the weird Sentinel-1 snake oil weirdness security software that keeps being peddled is going to have a really hard time running, and it's going to require a ton of exceptions from your PSP so that it can do what it wants to do and exfiltrate all the information it wants to. Anyway, slide 36 talks about how we're going to talk a little bit about troubleshooting these things. When you enable these things, they're a bit of a pain in the tuchus. When the official documentation makes a big deal about how pod security policies are evaluated in alphabetical order, in practice, this is not particularly an onerous thing, because in the way that I'm talking about laying this out, a given workload is only going to have access to 2 pod security policies, the fully restrictive one and the special case one that they have access to. So analyzing two policies is not a terrible deal, but the other problem is Kubernetes, when it shows you the error messages for these things in Kubernetes events, it will show you a union of every error message against every pod security policy that this workload has access to, which means that this thing can be a little bit of a bugger to actually triage. In what I've done as a tactic to, and if you go to the last slide, what I've done as a tactic to help mitigate this is in my dev environments, I have occasionally disabled the fully restrictive pod security policy while I'm iterating on fixing the workload that I'm working with. This reduces all of the errors down to just the PSP that I'm dealing with. So that makes reasoning about the error messages as sparse as they get, as Kubernetes gives you, at least possible to trace and figure out what's going on. Another very big tactic is you should be very explicit in your security contexts at both the pod level and at the container level, because those are 2 different lists of keys and values under the same heading at different levels of the gamble, because of course they are. Anyway, those are the very short version of how I have set up PSPs in the past. I should also mention that PSPs have kind of an interesting future. They have no comparison right now. There's no alternative right now if you want to do the same types of things, restrict privileged pods, stop people from doing host-only networking, et cetera. But PSPs are also possibly marked for deprecation at Kubernetes 1.22, at which point the Kubernetes API team is hoping that some CRD providers will have stepped up into this space rather than forcing the Kubernetes maintainers to maintain this thing. I don't know that I agree with that approach personally, but I understand the motivation. Anyway, that was a whirlwind tour of pod security policies. There is some pain here, but the huge upside that you gain becomes much more difficult to break container isolation if you've taken away all the interesting toys that attackers, and what be they white, gray, or black hat, use to break isolation. You've just made their job much harder, and therefore you've made your entire cluster much more secure. Anyway, any questions? I see a couple of them. Give me a second. I'm sorry, Eldon, that FluentD has triggered you. ... I just run all my weird security tooling as root and underlying host. Is it a bad idea? I have seen way too many security tools go completely gonzo on my hosts for me to really trust them, which is why I really like what Kubernetes limits on them. Like, you can only have half of a core, you can only have 3/4 of gig of RAM. And well, yeah, it's hard for them to stomp all over my workloads at that point. Regarding the exceptions, how do PSPs decide what is the higher priority between the general PSP and the exceptions PSP? So the way it works is kind of like a default deny firewall. what you do is you kind of work your way through all of the security policies until it finds one pod security policy that allows this particular workload. And as soon as it finds one that it uses it. If it falls through all of them and does not succeed any of them, the workload is denied. Does that answer your question, Shahar?
Yeah.
Okay. And Aaron answered that question. Okay. Anywho, what else? That was kind of a whirlwind tour, and so please ask questions if I blinded you.
Give them another minute and get any other questions in. I wish I had the Jeopardy music queued up. I'm a terrible host.
Yeah, I'll post the links.
Do you have any feelings about this being in core versus being CRDs?
I think that security and monitoring need to be first-class citizens of any ecosystem that is being built. So I think Kubernetes is in a weird spot in that it is now doing runtime restrictions on these things. And what I think this is interpretation on my part. I think what really scared the Kubernetes team was when they had to implement PSPs for both Windows workloads and for Linux workloads. And obviously two wildly different kernels with different execution environments. That scared them, and they probably did not want to be supporting multiple of those. However, I kind of view deprecating these as a dereliction of duty. So I don't know. I hear what they're dealing with, but that's one of the things that concerns me. So Lawrence, I threw the 2 links up there. Performance concerns, actually no. This is one of those things that is evaluated at pod launch time. So it may add a quarter of a second to your bootstrap time, but your Docker image pull is going to dwarf that by a couple of orders of magnitude. And once the workload's running, the PSP is not doing anything. At the end of the day, the PSP engine is working as both a mutating and a validating webhook, kind of at 2 different places in the execution stack. And so it's either going to modify some things to be more secure, then it's going to make sure that the final result is matching the policy, and then it's just going to let the workload through, or it's not at all. So this is kind of a front gate piece of security rather than a runtime piece of security. John Mason, what about tools like Twistlock? I have not worked with Twistlock, so I don't have a straight answer to that question.
You mentioned webhooks. Is there anything that you can't accomplish with a mutating webhook that you could accomplish, or a validating webhook that you could accomplish with a security policy?
The canonical answer to that question is, of course, yes. If you want to have your own homegrown way of doing this, you probably could, but that would be a whole lot of duplicative effort, and you'd end up basically re-implementing PSPs. So why not just use the official thing, which is going to be a lot more debugged and have a lot more people poking at it than your thing.
For sure. Thanks.
Cool. Looks like we don't have any other new questions coming in. So
Thank you, Moshe, for being a co-presenter.
Yeah. Thank you, Moshe, for handling the technical work there. Thank you, Jason, for the great content, buddy. Your talks are always some of my favorites. Next up, we have Moshe from SalesLoft coming to talk about how SalesLoft does continuous deployments.
Hey everyone, let me share my screen again. All right, so hey everyone, I'm Moshe. I work for SalesLoft as a site reliability engineer. My main role focuses on the platform resiliency, obviously around Kubernetes and the tooling that we write around it. I've been with SalesLoft for about 1.5 years now. Start with a little bit of stats of our production, and this is our production environment at SalesLoft. I would say, aside from the stateful workloads like databases and data stores, everything else runs on Kubernetes. So we're talking about 6 production clusters. We use 2 cloud providers. We use AWS. We run our clusters using KOPS. So we manage the control plane, we manage everything, and we have 2 clusters that are probably around 10 to 15% of our workload that runs on GKE. So managed Kubernetes on Google. We utilize HBAs and cluster autoscaler pretty heavily on both environments. As you can see, our daily average node count runs anywhere between 70 to 1,000 nodes at any given time. And to translate those to pods, we have about 6,000 to 8,000 pods running in total in production. And one thing we really take pride on is how fast we ship code to production. We have between 20 to 40 code deployments to production every day. I know that this is something that a lot of people get amazed with. So now we're going to talk about how we do that. So the key players in our CI/CD pipeline, GitHub is where we store all our code. That's our VCS basically. And this is where the entire pipeline kicks off. We use CodeCheck to run our test suites. We try to cover as much code as we can with unit tests and integration tests. So all that part happens on CodeCheck. CodeCheck is critical because if PR fails the tests, we cannot merge that. And of course, that code would not get deployed. So CodeCheck is kind of the gatekeeper for everything that goes to production. So these 2 are known to everyone tools. And now moving on to our in-house ones, we have K8, that is the Kubernetes Deployment API. For those of you that has been with us for a while, Alex did a talk about K8 about 1.5 years ago, covering most of that. You can also go to the YouTube channel and find that talk in our previous Meetup recording. And lastly, we have Panopticon that oversees the entire deployment. So K8 runs as a single instance per cluster. And as I mentioned earlier, we have 6 clusters in production. Panopticon is the component that oversees the entire process. So that's in a nutshell. And now we're going to talk a little bit about the in-house components. So K8 is our Kubernetes Deployment API, as we mentioned. That kind of follows up on what Jason mentioned earlier. We don't expose our Kubernetes API at all. They are not publicly accessible. So our interface to manage our workloads on Kubernetes would be through K8. So the advantage of doing something like that, and I'm gonna kind of shuffle the bullets when I talk, but we have a lot of business logic applied on our deployments. We logically group a large set of Kubernetes deployments, like the known deployment resource, under what we call an application. So for example, one of our microservices would consist of an API tier and 10 different types of workers that each one of those workers would be a deployment. So we have a total of 11 deployments that are stacked or grouped under the same app. And let's say we want to ship a new piece of code to that microservice. They all use the same image. So instead of going through 11 deployments and updating the image on each of those deployments, we would just say, hey, K8, deploy this shop for me in all of the clusters in production, all of the clusters that run this microservice, of course. Kate would just go ahead and do that. It'll oversee the entire process to make sure that the new pods that come online with the new code, they pass their health checks, they don't have any terminations, they become ready, and all the other out-of-the-box sanity checks that Kubernetes provides for us. So this handles the deployment, the overall deployment process at the micro level, because this is per cluster, as we mentioned, 6 production clusters, 1 K8 instance is equal to 1 Kubernetes cluster. Next up is Panopticon, our global deployment layer. This is where we instrument K8 because we don't want to manage every instance individually. Panopticon is built off of several components. We have a listener that is basically the API for Panopticon. We have an overseer, which follows the Kubernetes control pattern approach that we mentioned here. So the overseer is basically a Kubernetes controller that runs in a watch loop. All the Panopticon resources are CRDs. They are custom resources. We have things like steps, which we'll talk about in a minute, tasks. For every code deployment, that would be translated to a task that gets created by the listener. Inventory, which is basically every app has an inventory custom resource under Panopticon that tells us which clusters run this application, what's the currently running version, and so on. And lastly, we have things like target, which would be a K8 instance. So cluster would be equivalent to a target. Following up on what we said about K8, Panopticon is the part of the deployment that handles it at the macro level. So it oversees the entire process. Let's look at the workload for a second. That might give us a bit more information. So we're going to start off at the first bullet here. A developer merges his pull request, his or her pull request to GitHub. And number 2 consists of 2 parts. GitHub sends webhooks to both Panopticon and CodeShip at the same time. This is where we kind of split up for a minute. The Panopticon part, the listener, the API, gets that webhook, the merge request, creates a task, and then the task spins up a Panopticon worker that would come online, pull all the information it needs in order to get the code to get deployed. And at this point, the worker will just sit and wait. It'll keep pulling the PR on GitHub to get the check status results from CodeShip. So the second part of the webhook that is being sent is to CodeShip. CodeShip executes the test suite. And of course, if CodeShip passes, it'll mark the check on GitHub as succeeded. Otherwise, it'll mark it as failed. At this point, as soon as we get a result back from CodeShip, either success or failure, the worker would act accordingly. If the check failed, the worker would not deploy the code. It will mark the task as not processed. It'll say the test suite failed, so I'm not going to push that code to production. And if it succeeded, this is where the worker starts doing his job. So step 5, well, this is where we actually said that we create the task and pull the status. At this point, we have 3 different K8s here. We have K8 Middleton, Hudson, and Winslet, just to kind of simulate the clusters that we run. So the worker would kick off, supervise the deploy process in every K8 target that runs that application. So as we said, the worker would just asynchronously spin up a task in every K8 cluster and make sure that the code was successfully deployed in every cluster. As soon as everything succeeded, the K8 targets would let the worker know, well, actually, no, the worker pulls K8 targets. And as soon as he gets back the succeeded result, we get a post to our Slack and to the GitHub pull request saying, hey, this code was deployed. We're all good. One thing that doesn't appear here, if one of these clusters failed deploying the code, this is something that K8 would see. K8 would mark its process as failed. The worker would see it, mark the whole task as failed. And at this point, we even have a rollback process saying something on this new code might be broken because not all the pods became ready. I'm going to roll back this version to the previously known working version. And then everything else kind of gets undone. And we will also get a notification to Slack and GitHub PR saying this deployment failed. go check the logs and figure out why did it fail. This is where we would step in and start troubleshooting. So this entire thing happens automatically, and it saves a lot of hassle for us. That's the flow. Slightly deeper dive, looking at how we manage this whole thing. Oh, I see a question already about K8 and Panopticon being open source. Unfortunately, no. I don't have a good answer for that. I think at some point we may be able to, but we just didn't go through the hassle of open sourcing it. We might do at some point, but we don't have a plan at the moment. Sorry. All right, so a little info about how we do all this. So K8, as we mentioned, the instance that runs in every cluster would gather its inventory, or in other words, every app, every SalesLoft app is what we call, and you can see the label here. So every application that runs in the individual cluster would get gathered based on these labels. So every deployment that buries a SalesLoft app would be gathered by K8, and eventually it will propagate up to Panopticon. We do all that stuff using annotations and labels, and as you can see here. So an example for annotations is the information that we would use for where do we store our manifests. So even the Kubernetes manifests, not only the code, everything is stored in GitHub. So we have our own Git repository for manifests. We have our own Git repository for the code base and everything else. The user accounts on Panopticon and K8 that are actually allowed to deploy code, so that this is where we apply that layer of security. And we mentioned the grouping of the SalesLoft app and SalesLoft tier. A cool thing that we like to use, with the example I gave earlier, let's say we have an application that consists of 10 different deployments. So that in order for us not to have to manage every deployment with these labels and annotations, we would take one of them, mark it as the primary, and only the primary deployment of every application would have to store all these annotations. All the other member deployments only have to have a SalesLoft app that matches that same application, and it will be a part of that application stack. And so this is taken out of general deployment. This is where the Panopticon does its part. So this is an example of a predefined set of steps, how we handle the deployment. This is a CRD. Our group is payton.salesloft.com. We use Vue on Beta 1 at this point. The kind of steps is how we say when a certain deployment happens, when a certain code is get pushed, and that could be, for example, let's say we updated a manifest of that deployment. We, I don't know, we changed an annotation value. We decided to increase the resource requests. So the manifests would be a certain set of steps that we call manifests. And the example here is the deploy steps. And we can see that by the name. So that set of steps says what happens when I push new code to the code base, to the Git URL that we can see here. What happens? So this is where we will see the command sets, and we say, okay, when a new code got pushed to our demo app, let's build this app, and we do a token replacement here. So we can use that same template by replacing just the repository and the SalesLoft app name. Everything else stays the same. Deploy that app in that SHA. Run once global is a pretty cool concept that we introduced not too long ago. What that says is we have one global Docker registry, and that registry, I'm sorry, trying to follow up on the chat as well. Oh, sorry. Okay, I'll get to the questions in a minute. Since we have the one global Docker registry instance, let's say we pushed a new code and we want to build that image. There's no point in building the same image from 6 different clusters. We only need to build it once and push it once, because the same registry is exposed to all 6 clusters. So run global means, okay, just randomly pick one cluster, run the image builder pod in that cluster, push the image up, and once that was done, go ahead and do the set image part, which updates the image tag. So our versioning is done by looking at image tags. And on failure would say, okay, what happens if the deployment fails? Just like I mentioned in the workflow earlier, just do a K8 rollback, which says, okay, for that app, if you have this SHA running right now in your cluster, go ahead and roll that back to the previous image because something is apparently broken there. So let me look real quick if we have any questions that I want to answer before I move on. I see Alex already responded to some of those. Alex, is there anything else I need to talk about, or?
No, I've been trying to grab them as they come in.
All right, thanks. Okay, so moving on, I'm gonna do a quick demo, and I decided not to trust the demo gods on this one, so I pre-recorded it. Apologies in advance. In this demo, what we're gonna do is basically I created a quick demo app, and let me real quick just you know what, never mind. We have a simple app that consists of 2 different deployments. We have an API that just responds to a /version endpoint. We have a worker that would just run, in our example, it just writes a log line every minute. So it doesn't really do anything, but the whole point is showing we have a single application that is built off of 2 deployments. And we are going to merge a PR that just updates the version, and we're gonna see how everything else happens automatically. So let's see the magic happening. Oh, sorry, it's not what I wanted to click. All right, so here we are. And I'm gonna kick this off. So we're gonna see 4 split screens here. On the top left is where I'm gonna do all the PR changes. On the top right is where we're gonna do a quick curl loop to hit the version endpoint and see how it looks like. Bottom left is our pods. We can see that we have a worker pod and the demo itself, which is the API. And here on the bottom right, we just turn the logs to see the worker. We can see that the worker started and it's version v0.1.3. So here on the top left, I'm just checking out a branch right now, just as we do in production. And I'm gonna call that branch my demo. I'm gonna update the config. It's just a simple Flask API. I'll promote the version to 1.0.4, save it. All the other Git magic that happens, adding, committing, creating the pull request, and merging that. And as soon as we see the merge happens, within about 30 seconds, if you watch the bottom left part here, let's see. All right, the pull request created. And now we are going to merge it. For those, by the way, that like to use the CLI, all the local Git commands I'm sure everyone is aware of, but I just learned about a quick, cool tool that it's called Hub. It extends Git to interact with GitHub API for stuff like creating and merging pull requests automatically. So brew install Hub for y'all Mac users. So this is where our curl loop starts running. You can see that right now the API still replies with version 0.1.3. We see the pods here still running with the older version, but soon enough, we're gonna see new pods coming online. And I promise you, I did not leave the tmux session at any point. As soon as I merged the PR, everything else happened automatically. We see the new pods coming online. We see 0.1.4 replied on the API, and we see that a new worker came online with version 0.1.4, and it already started logging. So pretty fun, pretty cool way to handle our deployments. It saves a lot of time for us so that we don't have to deal with deployments. We have a lot of time to handle more interesting things, I guess. Let me look at questions real quick before I move back to the slides.
I've been answering them as they come, but feel free to, it might be a good idea to go through and read them out loud just for recording's sake.
All right, so let's see. Oh, well, I guess we're done with the demo. So yeah, I'll just put the slide here. Okay, so Anil asked about if K8 follows blue-green deployments, and the question is not right now. We do have that down the pipeline to add blue-green and canary deployments. We haven't got to it yet, but it is planned to get ahead. Aaron was asking if we're starting out with just Q clusters, how would you proceed to get to the CI/CD future you have? I guess in other words, let's say we just spun up a new cluster. The question is, how do we bring that to our workflow? I assume if that's indeed the question, then yeah, just like Alex answered, when we bring up a new cluster, all we have to do is install K8 on it. And as soon as K8 is installed and configured, and the respective target was created for Panopticon to interact with that cluster, everything else would happen automatically. We don't have to do other things to make it happen. Let's see. Shahar is asking, are these 6 clusters one logical cluster replicated in a bunch of locations? Otherwise, what if I don't want to, I'm not ready to update to the latest version of an image in my cluster? All right, so that's a good question. Right now, because we don't do canary deployments yet, when we merge something, let's say for our patent demo application, when we merge the code to master, that code would get pushed in every cluster. Potentially, something we can do is we can, in our set of steps that we saw earlier here, we have another option that we can add is target selectors. So we can say, let's say we work in multiple regions. So we have region A, region B, region C. Let's say we only want that set of steps to get applied to region A, then we would add a target selector saying only for region A, go ahead and push that code, and then this set of steps would only get applied for clusters that are in region A. And the nice thing about it is that we can utilize label selectors just as you would do with every other Kubernetes resource. So a target would have a label on it, and then we can use a selector to browse targets based on their labels. So that gives us the flexibility we need for sometimes saying, I only want that to get deployed in this region and not that region. So that's one example for that. Oh, and I see that Alex responded with the exact same thing that I just said. Let's see. Aaron was asking about Panopticon. Panopticon is also SalesLoft internal. Yeah, and as Alex said, we do hope to open source it eventually. Let's see. So there was a mention about gitkube.sh, which I am not familiar with. But yeah, I guess I'll look at it in a bit. All right, we have another question from Lawrence here. Nice update to skate the demo last year. Really good work. Thank you. Any concerns going forward if you could use or replace with a tool in the market? What alternatives did you or would you consider? So at SalesLoft, I don't think we personally ever evaluated another tool because K8 came in from, K8 was pretty much built from the beginning of time. And as soon as we started to grow to more than 1 or 2 clusters, this is where Panopticon came into the picture. About tools that are in the market, I'm familiar with Spinnaker a little bit because I tried that at a previous job. I think Spinnaker kind of tries to answer most of these same concerns. I haven't looked at it for about 2 years, so I'm not sure where they are today, but off the top of my head, this is what I can think of right now. Oh, and yeah, Tim mentions that we, as you can see here, by the way, we use the short form Payton. As instead of saying panopticon, we also say Payton in a lot of times. And there's, yeah, we do that. Any other questions? Give it about 10 more seconds.
I see we've got one person with their hand raised on the chat. If you want to put in a question, just go ahead and type it into the chat, Nina, and we'll answer it from there. Oh, that went down.
Went down. Okay, cool.
That's give me a minute just to see if any other questions come in.
All right, in the meantime, I'm gonna stop my share.
Cool. All right. Well, I think that covers us for questions. I haven't seen any others come in. So thanks, Moshe, for giving the talk. Really appreciate it, buddy. That was great content. Thank you to our other speakers, and thank you for everybody else for coming out. Just want to say, you know, we appreciate everybody kind of bearing with us while we experiment with these formats. Again, if you have any feedback on how you think we can improve on doing these virtually, since, you know, God knows when we'll all get together again in person, just shoot us a message either on Tech 404 or via the Meetup group on meetup.com. We'd love to hear your feedback or your suggestions. We're always looking for speakers, so if you're interested in being a presenter, we'd love to have you. Again, just message us by either those methods. The recording for this will be available on YouTube, and notes will be up on HackMD and in our GitHub repo. I'm going to go ahead and close down the recording and open up chat if anybody wants to just hang out and socialize. And again, thanks for coming out.
Thank you, Alex.